Hello all, welcome to Tech Capture. So in this video, we are going to discuss about a very trending terms in AI space, that is a MCP. So we'll see from basic what is MCP or a model context protocol, how it works, why we need MCP and how we can integrate MCP with the agents. So we'll talk about more details in MCP in our further video. So this will be a playlist, not a single video. So this video we are starting with a basics of MCP, how MCP works, what is the architecture of MCP, and we'll start creating the simple MCP servers at our local desktop. After that we will see how we can use MCP servers along with the ADK agent, how we can use a remote MCP servers, and how we can interact with external application using our LLM models. Okay, so all the things we are going to cover from the basics. So if you are new and just starting with the MCP, so this video will help you a lot. Just stay tuned till the end and you will learn a lot of things from this video. Okay, so let's get started. Okay, so let's start with a basic example. Okay, so let's say I'm using a Google Gemini and I'm interacting with Gemini. I'm just looking for some helps related to BigQuery using a Gemini. So I ask one question to Gemini, that is what is a Google Cloud BigQuery. So it gives me some details about Google Cloud BigQuery. Then I ask a next question, how to create a table in BigQuery. So it might give us steps how to create a BigQuery table from the console, and it also give us a SQL queries to create a table in the BigQuery. I'll just go next and I'll ask, okay, give me query to get a total count from my table in BigQuery. So I will give the table name, I will give the dataset name, and I will ask a Gemini to create query for me. So this will also Gemini will give me. Now the query the Gemini returned, I asked Gemini, okay, so now you go and run this query in my BigQuery. So it will not execute that query. That we know that Gemini directly will not go and execute our query in the BigQuery. I'll just show you the real-time demo here. So see, I'm asking please run the query in BigQuery, and what the response I got. Okay, as a large language model, I cannot directly access or execute queries within your actual environment. Okay, and this is the important thing. What it is saying, I do not have access, I do not have necessary credentials, permissions, or a direct interface to run live code against your data. So here we need a manual intervention. So Gemini can help me to get a SQL queries, it can help me to get the steps, but actually to go and create a table or actually go and run a queries, we need a human intervention. But what if I can provide these things to my LLMs? Okay, so this is my model, Gemini is my model. Okay, and now this is the context which is missing, that is unnecessary credentials, permissions, my project details, which dataset to run, and the table. So these things are the contexts which are currently missing, and that's why my model is not able to perform the end-to-end task. So here the MCP comes into the picture. So what is MCP? The model context protocol. Now let's take an example. If we start giving this data or start giving this context to the LLM, how it will work. Okay, so then the MCP comes into the picture. So this MCP is model context protocol, which is an open source standard designed by Anthropic, okay, which can help to connect a application to the external system. So let's take example our BigQuery. So BigQuery is external system to the Gemini or ChatGPT, but MCP protocol help to connect our LLM directly to the BigQuery or any external database. Okay, so this is introduced by Anthropic in November 24. Okay, as I mentioned, until the time it is gaining a lot of popularity because it is giving a power to LLM to directly interact with the external system, just like any database, a BigQuery, or any application which can expose as a MCP server. Okay, so now MCP operate as a client server architecture. So this we need to understand. So you cannot directly just give access to your LLM. So you have to create a MCP server. Okay, and then you have to create a client. So client can be a AI application which you are using. In our case, let's say we are using some AI application which is using Gemini or using the ChatGPT or OpenAI. That is our client, and server is a MCP server which is interacting with the external system. So we'll see all the details with hands-on demo. So MCP server expose resources, templates, and tools while MCP clients such as AI agent or LLMs consume this offering. Now just take an example. What is the expose a resource? So in our case, let's say the BigQuery. So BigQuery tables or data, these are the external resource, templates and the tools. So let's say we are having a multiple tools in, let's say, the BigQuery MCP server. One tool is to get the list of tables, so one tool to execute a query, one tool to, let's say, get some metadata about the table. So these are the tools, just like we discussed about the ADK tools earlier. So these are the tools which MCP server expose, and the AI application will use that tools. Okay, this is how it will work. So just take an example here how MCP works. So any your LLM model, this model will use MCP protocol, which is the standard used to connect to the external system. So it can be your database, it can be your Google Maps, or it can be your GitHub. So there was no standard earlier to connect your AI application to the external system. So Anthropic solved that problem, and it comes with the model context protocol, which is the standard to connect your LLM models or the AI application to the external sources. Okay, so this is the overall picture of how MCP works. We'll go more details, we'll see the demos, but this is how overall pictures looks like. What is MCP in one line? It is just the way to connect your LLM model to the external source. So external source can be your database, can be application, can be API, or any external system. Okay, so if it exposes the MCP servers, you can consume it using your AI application. Okay, so let's dig down more how it works. So I am giving the documentation here, you can refer it later, but just dig down more. Okay, so just break it down how the model context protocol actually works. So model we talked about is Gemini. Context is the external information and resources that LLM requires. Just go back to our previous example here, a BigQuery, then the BigQuery credentials, BigQuery permissions, and then we can talk about the BigQuery dataset name, project names, all these details, and the access to execute the SQL queries. So this is called as a context. Okay, so we are providing this context using a model context and protocol. So what is protocol? This is just a standardized set of rules, because now your LLM model is interacting with a BigQuery, then there should be a proper set of rules. How should be the request, how should be the response, how they should be interacting. Because if you talk about the web or internet, there is a standard HTTP protocol. So everyone use HTTP protocol to interact with the web. Okay, the same to interact your LLM application with the external system, this is the standard protocol, which is a model context protocol. Okay, so if I talk about databases, so there is a one MCP toolbox for the databases. Using this MCP toolbox and MCP server, you can connect to AlloIDB, you can connect to Bigtable, BigQuery, Cloud SQL. So whole Google Cloud data analytics ecosystem you can connect. You can connect to Spanner, Memory Store, Looker, MySQL, Postgres, SQLite, Neo4j, MongoDB. So you can connect to any of these databases from your agent. So it can be your ADK agent, or it can be your Gemini. So you can use this MCP toolbox to connect to your database and perform the operations. Okay, it can be writing the query, it can be reading some data, so it will use that. Okay, and after that, you can see, as I mentioned, it is getting a lot of popularity. So GitHub released their own MCP servers, Google Map is having own MCP servers, and this is the open source protocol. So you will see a lot of open source versions of these MCP servers. I will show you what all available servers are there in official MCP repository, and then Figma. So these are the some example. Okay, so I will show you what all MCP servers are currently available, and you can use that along with your LLM models. So it can be your Gemini, it can be Claude Desktop, it can be your OpenAI. So you can just use any LLM models, and you can use this MCP protocol to connect to the external system. So how this actually works, how your LLM models connect to the MCP protocol, how it connect to the external data source. So we'll see again how it works. So I'll just give you one more example of a Google Cloud ADK agent. So see, I ask my the general ADK agent, which is having the LLM capabilities. I ask, can you give me the best cafes near me? My location is Koregaon Park, Pune. because I haven't enabled my location. I just given the location. Okay, my location is Korega Park, and give me the nearby cafes. Now even though LLM is having a data, it trained on huge amount of data, what it mentioned, I do not have access to a real-time location data or a local business listing, and it could not answer me. This is my first agent. You can see the name. This is my just a normal first ADK agent, and it is suggesting you can check on Google Map, you can check on Zomato, you can check on Swiggy. But what if I given access directly to the Google Maps? Okay, instead of manually going and checking on the Google Maps, I want my agent to do all the operations. Okay, so then I created one MCP agent, not agent, MCP server with the Google Maps capability. I connected my Google Maps to the MCP servers, and I exposed that MCP servers, and my Google ADK will use that MCP server. Now once my ADK start using a MCP server, let's see how's the response. Okay, now you can see the same question I ask again, exactly same, nothing changed. Now it is using Google Map MCP server. It is getting the response from MCP tools. It is giving the response, and you can see it is giving the response from the Google Maps API. Okay, so this is the ADK agent we will create. I will show you the code walkthrough also how we created this, but this is how the difference when we are using a MCP server. We actually connect our agent, we actually connect our AI application to the external system. So here external system is a Google Map, and it is directly connecting to the Google Maps, getting the data and giving answer to your queries. Okay, so you don't need to go into 10 different places when you want to do some automation, when you want to work. So your agent can be your one place. You can do all the operation in your ADK agent itself. Okay, I'm just giving example of ADK. It can be your LangGraph agent, or you can your any agentic AI applications. Okay, so let's go again. So how actually this MCP works, because we are talking about, okay, we'll create MCP servers, we'll create AI application, but how the backend the things will work. Okay, so let's see here. This is our overall architecture. So whenever we use a MCP servers, there are three main component. One is MCP host, okay, one is MCP servers, and one is MCP client. So this is important, MCP servers. So whenever we see MCP servers, this is what connects to your external application. So here let's say example of SQL database or BigQuery. So your MCP servers will have some tools. Okay, so these tools are nothing but the Python function, we can say, or the API calls, which will, let's say example, there is one tool which will query the data. There will be one tool which can just get some metadata about the data. In Google Maps, there are tools to get the location, get the coordinate, get the direction, or show the nearby places. So there are different tools in Google Maps API, and we expose these all tools as a MCP servers. Okay, and once this MCP server is created and running, then you can connect your host. Now host is where your AI application is running. When we talk about Google ADK, so ADK is your MCP host where your agent is running. So how it works, so whenever you want to create to the MCP server, it will create one MCP client for each server. So there are 10 different MCP servers, so ADK will create 10 different client. Okay, so here let's say this MCP server is for database, so your agent will create one client. It will use this model context protocol. It will send request. Your client will send request, not your host. Your host is just to manage the client and manage the user connection and user queries. So it will, let's say user is here, it will get the user query. Okay, and let's say user is asking something about the database, then your MCP host will understand, okay, it has to route it to the MCP server of database, not the maps. Then it will create one client for your MCP servers, and it will send a request along with the query. So let's say your query is about get some data from the database or get the count from XYZ table. Then it decided, okay, it should go to this MCP server for the database. It will create a client. It will send request with some data. Now data, let's say I am requesting to get some data from XYZ table. Then that XYZ table will be some context, and that context has to be passed to this MCP context protocol. Okay, and then it will, client will send a request to the MCP protocol. MCP server will accept the request. It will just check, okay, user is requesting some data about XYZ a table, let's say it is about the querying the data, then it will call a required tool. Let's say it is for querying the data, it will call a query tool. Okay, so it is, let's say for some creating table, it will call another tool, and based on that it will create connection, it will do some operation, and it will give the response back. If it is for the querying the data, then it will give response back to your client, and then client, whatever the response you got, then your client will just summarize in the natural language and give the response back to the users. So this is how the overall flow work. For each MCP server there will be a MCP client. Okay, so now how it works, as I mentioned, MCP host is always your AI app or interface. It can be your VS code. So we'll be creating our first MCP server in our VS code locally. We'll be also creating our MCP server on the cloud desktop. We'll be also creating a whole agentic system using a Google Cloud ADK and MCP servers. We'll see all this demo, and it controls the permissions and approve AI action. So it will decide, okay, where to route the request, if user is eligible to call this MCP server. So all these things are decided by MCP host. Okay, and MCP server, it provide tools and data to AI. So tools is, as I mentioned, it can be some part of your coding, it can be a Python function, and data which is available in the database. So it provides access. So most of the cases, I would say 99.99%, this can be your read-only access. You will just expose this data with the read-only access. Okay, and you can see the example Google Map server, database, all these are external system which your MCP server exposes. The third is MCP client. It connects host to the server. As I mentioned, it will create a client and then you will make a request and response through the connections. So there are two different types of connections. So if you are using the local MCP server, it will create a studio like standard input output connections. If it is the remote MCP server, it will go via HTTP request. Okay, so this MCP client send request and get results. So your ask database server for top restaurant, then your MCP host decide the table, decide the query, and it will send to your MCP server. It will execute a query and then get response back to your client. This is how MCP works at the back end. This is the whole overall picture. Now why we need MCP? Because if you talk about the agent, the tools are already doing the same operation. Let's say if you want to execute some query on BigQuery, so BigQuery tool is an option, you can already do that with the BigQuery tools. Then why we need a MCP? So there is a very simple justification for that. Okay, let's say you are having agent 1 which is connecting to the database. So you have created a tools and you have written some, let's say 10 different function, one to query the data, to get the count, to get the metadata. So you created 10 different function for your database. Okay, now again, let's say you are having some multi agent or sub agent into that will use the same tools. You can share these tools across your sub agent, that is perfectly fine. But let's say you are having agent B and agent C also, which are connecting to the same database or a similar database, but your tool code will be similar. Because if you want to query the data on the database, it will be same code, only your query will change, your connection will change, but rest of your most of the code will remain same. So you are duplicating all your codes and effort. And what if, let's say there are multiple projects and they are doing the same operation, so for everyone you need to create a separate tools. So that is not a best practices, right? And if I give you example of GitHub, now let's say if agent want to create a GitHub repository, so there will be exactly the similar code that everyone wants to create a repository, right? So if there are 100 companies and 100 companies are writing their own code, they are working with the GitHub repository, but this is the standard, right? GitHub is a standard and everyone needs to create repository and the code will remain same. So what if GitHub exposed the MCP servers and provided a standard to create a GitHub repository using the Agentic AI? So that is how the MCP works. So that's why we need MCP, because it will just tools will just replicate, and their the scope is within your agent. They cannot be accessed outside of your agent until and unless shared. So that's how the MCP works. So in MCP you will have your database. On your database you will create a MCP servers connected to your MCP, connected to your database, and then you will create some tools which can be like querying the data or listing the tables or listing some metadata attributes, and then your agent will create MCP client and connect to your MCP server, not directly through the tools. So they will all connect to your MCP server tools. So this is the most efficient way when your AI application needs to connect with the external system. So hope this is clear now why we need a MCP server even though we are having tools. So this is basically, I'm giving example of a Google Cloud ADK, the same applicable with the other agentic systems as well. Now let's talk about a very common confusion about the MCP server, that is a local versus remote MCP server. What is a local server and what is a remote MCP server? So basically this local or a remote, this is the terminology used based on how the agent or a client access your MCP server. Let's say if you are a MCP host and MCP server, or I would say if your MCP client and your MCP servers runs on the same machine, then it is called MCP's local MCP server. If your MCP server running somewhere else and your AI application running somewhere else, then they need to interact with the HTTP, that is called a remote MCP server. If we are using the ADK or Google Agent Development Kit, mostly we wrap it with the MCP toolset or MCP tools, so we will use a local MCP servers. I will show example of the remote MCP servers as well. Okay, so this is the difference, and there are some tables just to differentiate. So what is MCP servers? Running on the same machine as your client, running a different machine or a cloud infrastructure when we talk about a remote MCP servers. So it uses as I mentioned, a studio protocol or studio communication channel like standard input output, and when it is a remote MCP server, it uses HTTP. So deployment, it is mainly used for testing and debugging. Okay, or it can wrap it with ADK and then deploy. Also, if you are using Agentic AI and the production grade ADK suite, then you can deploy your MCP server separately on Cloud Run, an example, and then you can use in your ADK, okay, as a remote MCP server. So only the agent on that machine will have access, but if you deploy the remote MCP server, then the multiple agent can access the same. So this is basically for the production grades best practices. You can use a remote MCP server, and this is the example ADK agent on your laptop using MCP server running via terminal or local system, and then it is deployed on the cloud. So this is the local versus a remote MCP server. So hope this is also clear. Now we will jump into the demos. Okay, so what is our plan about demo? Okay, so I'll show you. So first we will use a readily available MCP server. So there are a lot of MCP servers readily available. I have just given the links. I will show you also on my browser what are the MCP servers available. Okay, we will use a readily available MCP server, but we have to run it. Okay, so we will just our local system. Okay, then we will start using a create and use a Google Maps MCP server in VS Code and the Cloud desktop. So we'll see that as well. We'll work with the Google Maps MCP servers, then we will work with the Google Maps MCP servers with Google ADK, and then we will use a MCP toolbox for database. Using this, we will interact with a Google BigQuery or any other database using Google ADK, and after that we will create our custom MCP servers. So till this part we were using a readily available MCP servers, but at the last stage we will use a custom MCP servers which can integrate with our custom external system, and then we will see how we can use our custom MCP servers with the agent. Okay, so that's it for this video, and we'll start working on the demos from our next video.